guys, this is day 4 of our solving equations. Obviously, if you've not been here, this video is to help you to understand what we're doing in class, or maybe you're seeing it as part of our lesson. At any rate, write down this equation: negative 2x minus 2 plus 5x plus 1 equals 11. Let's review. We're going to, although we've been using a different method to learn how to solve equations, we're going to go back to our algebra tiles, which we were using initially when we learned expressions. So just to review, the green rectangle is a variable. The red rectangle is a negative variable. The blue square is a positive integer, like positive 1, and the red square is negative 1. Okay, so let's set, and then an equation is the equal sign lets us know that this is actually a scale, that the left side of the equation should always stay equal to the right side. And if it does not stay equal, it will be similar to, like if you and your friends are on a seesaw at Town Park, what's going to happen? If you and your good friend, who are the same weight or about, are on the scale, it stays balanced. But if your other friend, who's being funny, comes over and gets on the other side, what's going to happen? You're going to flip off. So, I meant for this to actually go like this. Tilt over. Anyway, it's not behaving. Tilt. So at any rate, the scale, so what you do on one side of the equation, you have to do on the other. All right, so let's set this up. Negative 2x, that's going to be 2 green or red. Can't hear you. It's going to be 2 red, okay? 2 negative x's. And then we have 2 negative squares, which are, oops, I was getting blue. 2 negative 1s, so negative 2, negative 1, negative 2. 5 plus 5x, that's 5 positive x's. And let's move this over so we have room. Now what you're doing is drawing these on your paper. You can make the executive decision to decide if do you want your positives to be regular rectangles, and maybe your negatives will be shaded in quickly shading. This is not art class, remember? So there's our 5 and then plus 1. All of that equals 11. Let's go maybe 3 sets of 3 plus 2 more would give us 11. Okay. 3 sets of 3 plus 2 more. 3 times 3 is 9 plus 2 is 11. Next odd number up. Okay, so what is the natural inclination that you have when you see rectangles and you see squares? Well, for me, I would think I would put all my rectangles together. Makes sense to me. What's that called? That's called combining like terms. So that means that we're going to circle our negative 2x, and let's circle our positive 5x. Okay, so obviously we can't add the 2 red to the 5 green and make purple. No, we can't do that. So what do we need to do? What is it called when these aren't the same size? Womp. Womp, womp. Okay. What is it called when I have a negative x and a positive x? They cancel each other out. That's called a zero pair. So let's get rid of our zero pairs. And what you're going to do is cross them out. And so I'll do what you're going to do. Cross them out. So we have 3 x's, and that makes sense. We have more green. 5x minus 2x, 3x. So let's write down 3x. Now let's deal with our integers. Negative 2. Let's move this over so you can see it. And we have a positive 1. Doesn't it make sense to add the negative 2 and the positive 1? Is that 3? You know it's not. How? 3 of what? Yeah, 3 squares, but they're not all the same, so you can't add them. But what can you do? Create a zero pair. If you owe me $1, you come in the next day and you only have $1 in your pocket, and you say, here you go, Miss Littles. Uh-oh. Oh, thank goodness. Here's your...
Mariah Bauer, please report to the middle school office. Mariah Bauer, please report to the middle school office.
So you add a square, so that's called a zero pair. You get rid of it. So negative 2 plus 1 is negative 1. And that makes sense because we have more negatives than positives. Okay, so that's going to be 3x minus 1 still equals 11. All right, so what are we dealing with here? Let's move these babies over. 1, 2, 3 x's. And then we have 11 here, but we still have this 1x that has a negative 1 there, and we don't want that. Why? Because we're trying to find the value of each x. Okay, so we need to get rid of this negative 1. How do we get rid of it? By adding in a positive 1. But it's a scale, so we don't want to go this way, right? So what do? If we add 1 here, we need to add 1 on the other side. If we're going to add 1, what does that do? It gets rid of it. Gets rid of it so that we have 3 whole x's. So let's do that down here. Instead of subtracting 1, or x reduced by 1, we restore it. Put the 1 back. When we restore it, we're left with 3 whole x's is equal to 12. All right. So we have 3 kids, grandma's grandkids, and then she has $12. She's a big spender. Okay. How much does each of you get? All of you are fascinating with money. You can do that super quick. And that's wonderful. So what do? We're trying to figure out how do we dole out this money. So we've got 3 here. Everybody gets 1. Everybody gets another 1. We want to know each x has a value of what? All right. Isn't that dandy? So each x has a value of 4. So for each grandbaby, everybody gets 4 buckaroos. Here you go. That's for you, Sally. That's for you, Joe. And that's for you, Jane. All right. So each x is 4. So let's do it on paper here. 3x, and we want to get the x by itself. What is the value of each x? Divide it into 3 parts. We're going to divide the 12 into 3 parts. X is equal to 4. All right. Now, let's do our check. Is x 4? Is that correct? Well, the way that we do our check is to rewrite our original problem. Negative 2x minus 2 plus 5x plus 1. So let's rewrite that. Negative 2x, and let's write check. Negative 2x minus 2 plus 5x plus 1 equals 11. And what are we trying to figure out? We're trying to determine, is x in fact 2? Is it 2? I don't know. You know, you guys hold up your boards. Here's my answer. Well, you're going to figure out for yourself by checking. Okay, so we have negative 2x, 4 negative 2's. So we're going to plug in 4 for x, minus 2 plus, my 5 does not look great. And we're going to plug in 4 for x, 5 x's, but now we know that x is 4, so we have 5 4's. Plus 1, does that equal 11? Negative 2 times 4. If we have 4 negative 2's, that's going to give us 8 negatives, minus 2. If we have 5 20's or 4 5's, 5 4's or 4 5's, that's 20. Plus 1 equals 11. Does this equal 11 is the question. Well, negative 8 and negative 2 is negative 10. Plus 20 plus 1. Does that equal 11? That's what we're trying to figure out. Is our solution correct? That's why I keep saying, does that equal 11? Next step. Negative 10 plus 20. Well, I have 20 positives and 10 negatives. Well, I have more positives, right? So I take the difference. 10 plus 1. Does that equal 11? Let's see. Ta-da! 11 equals 11. So we have solved multi-step equations and with negative coefficients and negative constants. So now what I want you to do is I'm going to go to the next page, and you are going to, if you're at home or in academic lab, write down these problems. Hold on. write down the problems, and press pause, write down the problems, and I'm going to amend this by saying solve and check. Okay? Thank you so much for your attention. Bye-bye.